So the idea now is to talk about the gift wrapping algorithm, also known in the two-dimensional plane as the Jarvis arch, which is an algorithm to calculate and identify the convex core of a set of points. The running time is the complexity running time is O of nh, where n is the number of points and h is the number of points in the boundaries of the convex hull. You can see here the idea of the algorithm. The idea is for each point, I start with a point that must be on the convex hull. For example, I take the leftmost point, and this is on the convex hull, so I start with this. Now what I do, I look at all the other points, which are n points, and look for the point which all the other points are to the right of this. And how can I do that? Using a polar angle, I can look at the angle here and look for the point which makes the angle here to be the smallest. This will be the point that all the other points are to the right of this. So I check from this point to that point, from this point to that point, for this point to that point, for this point to that point, and for each line, I calculate what is the polar angle between this and the line. And the line, the segment between the 2 points that creates the smallest, let's say, polar angle here, or if you are looking at this angle, so the highest, the biggest, it depends on how you want to calculate the angle between the points, but the idea is that I want the segment that all the other points are to the right. If you are going from the downward direction, so you want the lines that all the other points are to the left. Now you can understand the complexity of the algorithm because when I try each segment to every other points, I do n search, I mean n times, I check n points. In the next iteration n minus 1 and the next iteration n minus 2, but the idea is n points O of n, and how many times I do this search with the n points, the number of points on the convex hull. If I have n h points, so I do it h times. So the time complexity is n time O of n times h. So this algorithm is sensitive on the output, namely the number of points in the convex hull, on the convex hull itself, which we call h, this number. So again, if you understood correctly, I tried to create the lines that all the other points are to the right of it. If we're looking on this segment, they are to the right. 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 This segment, they are to the right of it. This segment and that segment, until I hit the point from which I started from. This completes the calculation of the convex hull. So this is the idea of this wrapping algorithm, gift wrapping algorithm, because it's like wrapping a gift. This is where the name came from, also the Jarvis march. And this is the time complexity, which is sensitive on the output. And this you can see here the angles, how you can choose the one with the if I look from here to here, the angle can be much bigger. If I look from here to here, the angle from here can be bigger. But you can calculate the angle in different ways. So the idea is if you want to go this direction, all the other points are to the right. If you're going in this direction and start like this, so all the points are to the left. This is the idea, and you are wrapping it until you get again to the point you started with. Remember that the starting point should be on the convex hull, so you can look for it like the leftmost point uh, on your points, on your set of points. So this is another method for calculating and identifying on computing the convex hull gift wrapping algorithm. Thank you very much. If there are any mistakes, please correct me, and that's it.